to solve an example of hypothesis test. 1 liter milk cartons should have the mean content of 1000 milliliters. To check whether the mean has changed, we select 50 cartons randomly and find the mean value of this sample. And we see that the mean of the sample is 995 milliliters. Because it is the mean of the sample, we denote it by X bar. We assume that the standard deviation of all cartons content is 25 milliliters. Because it is the standard deviation of all cartons, it is the standard deviation of the population, and we denote it by sigma. Now we are going to check whether the sample provides enough evidence at 5% level of significance that the population mean has changed or not. So here we wish to provide evidence from sample that the mean value is different from 1000 milliliters. So actually we would like to show that mu is not equal to 1000 milliliters. So it is our alternative hypothesis here. So we define the alternative hypothesis as mu not equal to 1000 milliliters. So the null hypothesis is mu equal to 1000 milliliters. In this question, actually, we want to reject H0 if the mean value of the sample is sufficiently different from 1000 milliliters. It means that it is sufficiently smaller than 1000 or sufficiently larger than 1000. It means that if the sample mean is sufficiently small, is in this area, or sufficiently larger than 1000, we reject the null hypothesis. So this is the rejection region. And you know that the area of the rejection region is nothing but the level of significance. And here in this question, the level of significance is 0.05. And you see that half of that is here, half over 2, 0.25, and half over 2, 0.025. Okay? Now we have to find the Z calculated. In order to find it, we have to see which distribution is useful. Since sigma is known in this question, we use Z. So the test statistic here is the Z calculated equals to X bar minus mu 0 over sigma over square root of n, and this is normally distributed. Why? Because the sample size here is 50, which is large enough. It is greater than 30, so by central limit theorem, we can use normal distribution here. The z calculated equals to x bar 995 minus 1000 divided by sigma 25 over square root of 50, and it is negative 1.41. Oops, let me come back. Okay, now we have to find these two values, these two z values, to check whether the z calculated is in the rejection area or not. So here we have to find these negative z of alpha over 2 and z of alpha over 2 here. These are the z criticals. So we have to find the z that the probability of z less than negative of z of alpha over 2 is 0.025. If I have a look at the table, you see that the negative of z of alpha over 2 is negative 1.96. So the z criticals are positive and negative of 1.96. So this one is negative 1.96 and this one is 1.96. Okay, when we look at the z calculated, we see that the z calculated is here, negative 1.41. It is not in the rejection area, and we say that we cannot reject H0 since the negative 1.41 is between negative 1.96 and positive 1.96 here, and this one is the z calculator. Now we can draw the conclusion at the end and say that we cannot reject H0 at 5% level of significance. It means that the sample does not provide enough evidence against H0. So we can conclude at the end that the average volume of milk in 1 liter cartoon is not significantly different from 1000, different from 1000 milliliters, and we do not have enough evidence to reject H0. Thanks for watching this video.